Tonight on The Sleepy Scientist, we journey back through time, not with a rush, but with a gentle drift, to Earth's earliest moments. Imagine a world still forming, its surface veiled in swirling mists and warm, dense atmospheric clouds, beneath which lay a vast dark expanse of water. This was our planet's primordial ocean, a quiet, immense cradle, holding within its depths the very first whispers of life. You might envision this ancient sea as a colossal, liquid laboratory, simmering gently under an unfamiliar sky. Volcanic eruptions silently pierced its surface, adding minerals and gases, creating a rich chemical brew. Over countless eons, as the Earth cooled, relentless rains filled the deep basins, slowly shaping the contours of this watery realm. Within these warm, nutrient-rich waters, sheltered from the harsh radiation above, the most fundamental processes began to unfold. It was here, in this tranquil, dark expanse, that life's first breath was taken. Not with a roar, but with a quiet, patient chemical assembly. Simple, single-celled organisms, invisible to the unaided eye, began their humble existence. These pioneers were tiny, self-replicating packages of matter, adrift in the colossal ocean. They drew their energy not from the sun, which barely penetrated the deep, but from the chemical reactions around them, a process known as chemosynthesis. Their quiet proliferation across the ocean floor was the universe's earliest testament to life's tenacity. Millions upon millions of years drifted by, like cosmic dust settling. These early life forms slowly diversified, evolving into slightly more complex structures. Ancient plankton, tiny, delicate organisms, began their quiet, rhythmic dance in the sunlit upper layers of the water, near the surface where a faint light might eventually reach. Their presence was a soft hum in the vast silence. A silent turning point. As some of these single-celled beings, the cyanobacteria, discovered a new way to harvest energy from the sun, a profound transformation began. They started to breathe out a gas that would fundamentally alter our world, oxygen. This oxygen, slowly accumulating over immense stretches of time, first saturated the oceans, then gradually began to diffuse into the atmosphere. This patient, biological alchemy was one of the most significant events in Earth's history, shaping the very air we breathe. The oceans were not merely a backdrop, they were the active engine of this planetary evolution, their vastness absorbing and distributing this life-giving gas. Across these geological timescales, the slow dance of marine adaptation unfolded. From simple cells emerged more intricate forms, subtly exploring the vast aqueous world. The first multicellular creatures, with their gentle, almost imperceptible movements, began to take shape in the depths. You can imagine them, soft-bodied and ethereal, silently navigating a world still mostly dark and mysterious. And within this enduring mystery of the deep ocean, an even more captivating phenomenon emerged. In the permanent darkness, far from any surface light, some creatures began to produce their own illumination. Bioluminescent beings, like tiny, living stars, glowed in the black abyss. A soft, otherworldly shimmer, a quiet, internal magic, allowing communication, hunting and defense in a realm where light was otherwise absent. Their existence whispers of the deep's profound quietude and the boundless inventiveness of life. The ocean, timeless and vast, continues its quiet work, its ancient currents still flowing. It holds within its depths echoes of life's first stirrings, a gentle reminder that even the grandest transformations begin with the smallest, most patient whispers, unfolding across ages, always moving, always adapting, always holding the promise of discovery in its silent, deep embrace. Imagine, if you will, the profound silence of Earth's earliest waters, a stillness undisturbed by the sounds we know today. We journey deeper now, into the very heart of that ancient realm, to explore not just the presence of early life, but its very genesis, its quiet awakening. It is a story whispered through the eons, written in the very rocks beneath our feet, and within the chemical makeup of the world around us. You might picture deep-sea vents, silently emerging from the ocean floor, releasing plumes of superheated, mineral-rich water. These were not the vibrant ecosystems we see today, but rather primordial chimneys, gently exhaling chemical nourishment into the dark abyss. In these chemically active environments, sheltered from the chaotic surface, the raw ingredients for life stirred. Simple organic molecules, formed perhaps in space or forged in volcanic heat, began a slow, unhurried dance. Over an immense expanse of time, these molecules quietly assembled. It was a process of patient, repetitive experimentation, guided by the immutable laws of chemistry. Eventually, membrane-bound structures, the precursors to cells, began to form. They were microscopic, fragile envelopes, enclosing a special internal environment, separate from the surrounding ocean. This was the birth of the first microbial life, the most ancient architects of our world. These earliest forms were not complex beings, but rather exquisitely simple, self-replicating entities. Their entire existence revolved around absorbing energy and nutrients from their surroundings, growing, and then gently dividing, creating carbon copies of themselves. This quiet, persistent process of replication, unfolding across millions of years, populated the early oceans with an unseen, yet profoundly powerful, microbial soup. These tiny architects, though invisible, began to transform their world. They weren't merely passive residents, they were active agents of change. As they metabolized, they subtly altered the ocean's chemistry, precipitating minerals, creating new compounds, and laying down the very foundations of early sediment layers. You can almost sense the gentle, continuous hum of their unseen activity, a biological symphony played out on a microscopic scale. Among these microbial pioneers were the ancestors of cyanobacteria, those quiet revolutionaries we touched upon earlier. Their discovery of photosynthesis, the ability to harness sunlight's gentle energy, was a momentous evolutionary leap. Slowly, almost imperceptibly, these single-celled organisms began to release oxygen as a byproduct of their light-driven metabolism. This wasn't a sudden burst, but a continuous, soft exhalation of gas that, over vast stretches of geological time, accumulated in the oceans and eventually diffused into the atmosphere. This patient, deliberate work of microbial life slowly transitioned Earth from a chemically dominated world to a biologically driven one. They were the original engineers, building the very scaffolding upon which all future, more complex life would arise. Their simple existence laid the groundwork for oxygen-rich environments, paving the way for larger, more energy-intensive organisms. The legacy of these ancient architects is all around us, a testament to the enduring power of the small and the patient. In the quiet depths of our own oceans, and within the very cells of our bodies, we carry echoes of these primordial beginnings. We are connected to that initial spark, that gentle, persistent thrum of life that began in the dark, warm waters, a reminder of the quiet wonder of existence, stretching back to Earth's earliest serene whispers. Let us now descend further, beyond the sunlit surface waters, into the profound and silent depths where light does not reach. Here, in the great oceanic abyss, a different world unfolds, one shaped not by the gentle warmth of the sun, but by the immutable forces of crushing pressure and eternal night. It is a realm of quiet mystery, where life's ingenuity shines with a soft, persistent glow against an immense, dark canvas. You might imagine this deep-sea environment as a vast hushed cathedral of water, where every cubic centimeter bears the weight of miles of ocean above. The pressure here is tremendous, far beyond anything experienced on land, yet life thrives, adapted to this constant, deep embrace. Organisms in these depths have evolved in remarkable ways, their bodies often soft and gelatinous, designed to yield to the immense forces rather than resist them. Gas-filled organs, common in shallower species, are rarely found here, as they would simply collapse under the weight. Instead, the cells of these creatures are often filled with a balanced composition of fluids, allowing them to remain structurally sound, quietly maintaining their form in this extraordinary environment. In this world of perpetual darkness, the concept of day and night simply ceases to exist. The energy from the sun, which fuels nearly all life on Earth, cannot penetrate these profound depths. Yet, life persists, sustained by ingenious adaptations. Many deep-sea creatures possess an internal light, a gentle ethereal glow, known as bioluminescence. Imagine a soft, shimmering display of living light, dancing in the quiet dark. This silent luminescence serves many purposes: a faint beacon to attract a mate, a sudden flash to startle a predator, or a subtle lure to draw in unsuspecting prey. It is a silent language of light, a testament to life's creative power, in the face of absolute darkness. Without the sun's guiding light, other senses become acutely honed. Many abyssal creatures have evolved enormous, light-sensitive eyes, capable of capturing the faintest glimmer of bioluminescence from miles away. Like quiet watchers in the vast expanse, others rely on an exquisitely developed sense of smell or touch, navigating their world through chemical signals and subtle vibrations, feeling their way through the endless night. Their world is one of soft echoes and gentle currents, where every tiny shift in water chemistry tells a story. The foundation of life in these sunless realms is often not photosynthesis, but chemosynthesis, or the gentle descent of organic matter from above. Marine snow, as it is sometimes called, is a continuous, soft shower of detritus, tiny particles of dead organisms, waste products and sediment, slowly drifting down from the productive upper layers. This gentle rain provides a steady, albeit sparse, food source for the patient inhabitants of the deep. Here, life moves at a slower rhythm. Metabolism slows, growth is unhurried, and lifespans can be extraordinarily long, a quiet testament to enduring existence in a resource-limited world. The deep ocean remains a frontier of discovery, a vast, mostly unexplored territory. Its hidden ecosystems, adapted to extreme pressure and endless night, remind us of the boundless resilience and quiet inventiveness of life. These creatures, enduring in their profound silence and soft luminescence, whisper secrets of adaptation, challenging our assumptions about what is possible, and inviting us to contemplate the deep, unending mysteries that still lie veiled beneath the waves. Their quiet existence is a profound reflection on nature's unwavering ability to find a way, even in the most challenging of worlds. Our journey now takes us deeper still, into pockets of vibrant existence nestled within the vast, cold silence of the abyssal plain. Imagine oases of life, warm and teeming, arising unexpectedly from the ocean floor itself, bathed not in sunlight, but in a chemical glow. These are the chemosynthetic havens, realms where life thrives in ways that once seemed unimaginable. You might picture plumes of dark, mineral-rich water, gently rising from towering chimneys known as hydrothermal vents. These are fissures in the Earth's crust, silently exhaling geothermally heated fluids, rich in hydrogen sulfide, methane, and various metals. In the profound absence of sunlight, these chemicals become the very breath of life for an entire ecosystem. This is the domain of chemosynthesis, a quiet miracle where energy is derived not from the sun's distant warmth, but from the raw chemical power of the Earth's interior. At the very foundation of these unique ecosystems are specialized microorganisms. These microscopic beings, invisible to our eyes, are the primary producers here, much like plants on land or phytoplankton in the upper ocean. They do not photosynthesize. Instead, they oxidize the chemical compounds released by the vents, extracting energy to build their own organic matter. Their quiet, continuous work forms the base of an entirely independent food web, thriving in perpetual night. Around these thriving microbial mats, a fascinating array of larger creatures slowly gathers. You might observe vast colonies of giant tube worms, their vibrant red plumes swaying gently in the subtle currents, absorbing nutrients from the water. These remarkable animals have no mouths, no digestive tracts. Instead, they harbor billions of chemosynthetic bacteria within their bodies, living in a symbiotic relationship. The bacteria provide nourishment, and in return, the worm offers a sheltered home. This silent partnership allows them to grow to impressive sizes, some reaching several meters in length, their presence a testament to life's adaptability. Blind shrimp, pale crabs, and enormous clams also populate these serene environments. They feed on the microbial mats, or on each other, creating a delicate, interconnected web of life. Each creature is exquisitely adapted to this extreme environment, to the crushing pressure, the toxic chemicals, and the intense heat fluctuations around the vents. Their bodies are built to withstand, to utilize and to flourish in conditions that would be lethal to most other forms of life. The discovery of these chemosynthetic havens fundamentally reshaped our understanding of where and how life can exist. It revealed that life is not solely dependent on the sun's energy, offering a profound insight into the resilience of biological processes. It also sparked quiet contemplation among scientists, wondering if similar forms of life might exist beneath the icy moons of distant planets, warmed by internal geological forces rather than a distant star. These deep-sea realms, these glowing chemical gardens, stand as quiet monuments to life's boundless ingenuity. They remind us that even in the harshest, most desolate corners of our world, life finds a way to take root, to thrive, and to create beauty. The silent dance of chemicals becoming life, unfolding in the deep, is a gentle whisper of the universe's enduring capacity for wonder, an endless source of quiet contemplation about the miraculous fabric of existence. Tonight, our quiet exploration of ancient oceans leads us forward in time, millions upon millions of years beyond the microbial beginnings, to an era when colossal, air-breathing creatures gracefully navigated the vast, sunlit waters. Imagine the serene expanse of the Mesozoic seas, a world where the dominant forms of life were not yet the great whales of today, but a different lineage of magnificent marine beings, the great marine reptiles. These fascinating creatures, unlike the dinosaurs that walked on land, had quietly returned to the ocean, their ancestral home, after a period of terrestrial evolution. It was a profound journey of adaptation, a slow, patient reshaping of their bodies over countless generations, allowing them to once again embrace the fluid embrace of the deep. You might envision them as silent, powerful shadows gliding beneath the waves, perfectly attuned to their aquatic environment. Consider the ichthyosaurs, often described as the fish lizards. Their sleek, dolphin-like bodies were marvels of hydrodynamic design, enabling them to move with smooth, effortless grace through the water. Their large, gentle eyes gazed into the ancient depths, perhaps scanning for schools of fish or squid, their main sustenance. With powerful, crescent-shaped tails providing propulsion and 4 paddle-like flippers for stability, they navigated the open ocean with an elegance that speaks of deep, evolutionary wisdom. Unlike most reptiles, ichthyosaurs gave birth to live young in the water, a quiet testimony to their complete commitment to marine life. Then there were the plesiosaurs, with their characteristically long sinuous necks, and 4 immense, wing-like flippers. They might have propelled themselves through the water with a slow, powerful, almost flying motion, using all 4 limbs in a gentle, rhythmic ballet. Their small heads, atop those elongated necks, likely allowed them to quietly ambush schooling fish or darting cephalopods without disturbing the water too much. Some, like the short-necked pliosaurs, were more robust, immense predators, but even their presence in the vastness of the ocean would have been a profound, deliberate movement, a quiet power. And finally, the mosasaurs, latecomers to this ancient marine stage, yet swift to assert a quiet dominance. These were truly immense, ocean-going lizards, related to modern snakes and monitor lizards. With streamlined bodies and powerful flattened tails for propulsion, they moved through the water with a subtle, serpentine grace. Their jaws, capable of unhinging, allowed them to engulf considerable prey, silently asserting their role as apex predators in these ancient seas. Their reign was a period of ecological stability, where the ocean sustained these magnificent forms for millions of years. The oceans during the Mesozoic era were a tapestry of life, from the smallest plankton to these colossal marine reptiles. They demonstrate the ocean's profound capacity to foster and shape life in myriad forms. The quiet ebb and flow of tides, the gentle currents, and the vast open spaces provided the stage for their enduring existence, a period of quiet majesty before the world shifted once more. Their passing, like their arrival, was a part of Earth's grand, unhurried narrative, leaving behind only fossilized whispers of their once magnificent reign in the deep. Our journey through time now leads us to contemplate a profound shift, a quiet turning point, in the long unfolding story of Earth's oceans. We previously observed the majestic reign of the great Mesozoic marine reptiles, those magnificent creatures that swam with such effortless grace through ancient seas. Tonight we gently consider their eventual absence, the soft echoes of extinction, and the enduring legacy they left behind. Even the most dominant forms of life, those that appear to hold an unwavering grasp on their ecosystems, are subject to the grand, unhurried pace of planetary change. For the ichthyosaurs, plesiosaurs and mosasaurs, their long era of quiet dominion eventually came to an end, a slow fade, orchestrated by subtle shifts in the global environment, culminating in a series of events that rippled through every corner of the Earth. You might imagine a quiet perturbation in the cosmic dance, a distant visitor from space, its gentle impact eventually sending waves of profound alteration across the planet. This event, occurring millions of years ago, initiated a period of significant environmental disruption, particularly affecting the delicate balance of marine ecosystems. The primary producers, the tiny plankton that formed the very base of the ocean's food web, were especially vulnerable to changes in sunlight and ocean chemistry. As these foundational food sources diminished, the larger creatures, dependent on them, began to experience a quiet struggle for survival. The vast, efficient hunters of the Mesozoic seas, accustomed to abundant prey, found their world slowly changing around them. It was not a sudden dramatic disappearance, but rather a gradual decline, a gentle dismantling of ancient food chains that had sustained life for millions of years. The oceans themselves changed. Subtle shifts in temperature, ocean currents and oxygen levels created an environment less hospitable for these specialized marine reptiles. Their remarkable adaptations, so perfect for their time, became less effective as their world transformed. Over generations their numbers quietly dwindled, one species after another, until their mighty presence became a memory, preserved only in the fossilized whispers embedded within ancient ocean sediments. With their passing, a vast ecological space opened up, a quiet void in the marine world. This absence allowed other forms of life, smaller and perhaps more resilient to change, to slowly begin their own ascendance. It was an invitation for new evolutionary pathways to be explored, for different adaptations to take root. The oceans, ever-flowing and ever-changing, continued their quiet work of nurturing life, ready to embrace new inhabitants. The legacy of these ancient ocean predators, though they are long gone, endures. Their existence, their adaptations, and their ultimate disappearance tell a profound story of life's interconnectedness and the continuous cycle of change that defines our planet's biological history. They remind us that all life, no matter how grand, is part of a larger, evolving tapestry, woven by the quiet forces of nature and time. And so, the oceans continue their quiet song, holding within their depths the memories of past reigns, and the promise of future forms. The echoes of these great reptilian swimmers gently remind us of life's perpetual journey, its endless capacity for transformation, and the deep silent wisdom held within the Earth's timeless waters. Tonight, we turn our gentle attention to the unseen forces that have always shaped our planet's vast blue heart, the quiet, persistent rhythms of the deep ocean currents. Imagine the immense body of water that cradles our world, not as a static, still expanse, but as a dynamic, flowing system, driven by ancient ceaseless pulses. These unseen rivers beneath the surface are the silent architects of global climate and the patient transporters of life itself. You might envision them as a colossal, slow-moving conveyor belt, silently traversing the entire globe. These currents are set in motion by subtle, yet powerful forces, differences in water temperature and salinity. Cold, dense water near the poles gently sinks and begins a long, unhurried journey along the ocean floor, while warmer, lighter water near the equator remains closer to the surface, flowing in the opposite direction. This continuous circulation, known as the thermohaline circulation, acts as a gentle, planetary embrace, distributing heat and coolness across vast distances. This grand oceanic pulse has profound implications for Earth's climate, both in ancient times and today. It is a slow, rhythmic breath, moderating temperatures and preventing extreme thermal imbalances. In the quiet, unhurried passage of geological time, these currents have subtly influenced ice ages and warming periods, directing the flow of energy that shapes the very atmosphere above the waves. Their influence is a gentle, steady hand, guiding the planet's atmospheric patterns. Beyond climate, these silent currents are also the tireless transporters of life's vital ingredients. Imagine them carrying a continuous, unseen shower of nutrients, dissolved minerals and organic matter, from one ocean basin to another. Upwellings, where deep, nutrient-rich waters gently rise to the surface, create fertile feeding grounds, nurturing vast blooms of phytoplankton, those microscopic life forms that form the very base of the ocean's food web. In the quiet depths, these nutrients are a continuous sustenance, a soft rainfall in a world without light. For life itself, these currents have been both a pathway and a sculptor. Microscopic larvae drift on these moving waters, undertaking immense, passive migrations, connecting distant populations, and allowing species to spread across the globe. Even larger marine creatures, from ancient fish to modern whales, instinctively navigate by these persistent flows, using them to conserve energy during their long migratory journeys. The currents are a silent roadmap, guiding the slow dance of evolution and dispersal. Over millions of years, these oceanic rhythms have also sculpted the very geology of the seafloor. They transport vast quantities of sediment, carving channels, building underwater dunes, and laying down layer upon layer of finely sorted particles. Researchers, studying these ancient sediment layers, can read the quiet history of past current patterns, revealing tales of long-vanished ocean basins and the subtle shifts of our dynamic planet. The pulse of the ancient oceans, then, was not merely a physical phenomenon, it was a fundamental force, a quiet, continuous partner in the grand, unhurried unfolding of life. From the earliest single-celled organisms, gently carried to new environments, to the colossal marine reptiles whose hunting grounds were shaped by nutrient-rich waters, these unseen currents have always been there, a constant, deep rhythm. They remind us of the profound interconnectedness of Earth's systems, a gentle, timeless flow beneath the surface, silently orchestrating the planet's most profound transformations. A continuous, quiet whisper of universal order. Let us now contemplate the quiet respiration of our planet's great oceans. A slow, continuous exchange that echoes deep within its abyssal realms. Imagine the ocean as a colossal lung, silently drawing in vital elements, processing them, and distributing them to its deepest, most mysterious corners. This ancient, rhythmic breathing has been essential for shaping life, particularly within the sunless, high-pressure environments we have begun to explore. From the surface, where sunlight dances and phytoplankton flourish, a crucial element embarks on a long, unhurried journey downward: oxygen. These microscopic producers, the great oxygenators of our world, release this life-sustaining gas into the upper layers. But how does it reach the abyss, miles below, where no plant can grow? It is carried by the same majestic, unseen currents that we have gently observed before. As cold, oxygen-rich waters sink in the polar regions, they begin their slow, deep trajectory across ocean basins, acting as conduits of fresh air for the creatures dwelling far below. This process is like a silent, deep inhalation and exhalation for the entire planet. The ocean's density-driven circulation ensures that even the most remote trenches receive a gentle, continuous supply of oxygenated water. Without this profound oceanic breathing, the abyssal plains would be entirely devoid of complex life, remaining barren and chemically inert. It is a subtle, yet powerful testament to the interconnectedness of all oceanic layers, from the sunlit surface to the eternal night of the deep. Beyond oxygen, the oceanic lungs also transport essential nourishment. We have touched upon marine snow, that soft continuous shower of organic particles descending from the productive surface waters. This gentle rain of detritus is composed of dead organisms, waste and shed cells, representing fixed carbon and vital nutrients. As this snow quietly drifts through the water column, it carries the building blocks of life, effectively breathing sustenance into the deep-sea ecosystems. This quiet, downward flux provides the caloric energy for many abyssal scavengers and filter feeders, connecting their existence to the vibrant, photosynthetic activity occurring in the distant sunlit zone. The availability of oxygen, often scarce but always crucial, has profoundly influenced the evolution of life in these deep, dark realms. Where oxygen is more readily available, such as near deep-sea currents, a greater diversity of animals can thrive. Where it is exceptionally low, life adapts in extraordinary ways. Creatures develop specialized respiratory pigments, ultra-efficient gills, or simply embrace a slower metabolism, moving with a quiet, unhurried pace that conserves every bit of precious energy. You can almost feel the gentle pulse of their adaptation, designed to make the most of every oxygen molecule. For millions upon millions of years, these oceanic cycles have been diligently at work, continuously refreshing the deep, distributing energy, and shaping the evolutionary pathways of countless species. They reveal the profound and subtle mechanisms by which our planet sustains its biological wonders. The ocean, in its vastness, acts not just as a cradle, but as a living, breathing entity, its ancient cycles tirelessly circulating life's essentials. This enduring process, this quiet, deep breathing of the oceans, reminds us of the delicate, yet robust balance that governs our world. It speaks to the wonder of natural systems, constantly at work, ensuring the continuation of life in all its myriad forms, even in the most challenging environments. It is a comforting thought, a gentle whisper of the Earth's continuous embrace, inviting us to rest in the profound wisdom of its ancient rhythmic heart. Tonight, our gentle drift takes us to the truly silent realms of the abyssal deep, where the familiar senses of the surface world are rendered almost meaningless. In this eternal night, where the sun's warmth and light never penetrate, life has evolved extraordinary ways to perceive and communicate. It is a world of sensory silence, yet paradoxically, it is alive with subtle signals, a quiet symphony of light and chemical whispers. You might imagine yourself suspended in this vast inky blackness, where the very concept of up or down seems to dissolve. Here, vision as we know it is largely absent, replaced by a more mystical form of perception, bioluminescence. This is the ability of living organisms to create their own light, not through heat, but through a gentle chemical reaction within their bodies. It manifests in myriad forms: a soft continuous glow from bacteria living on a fish, a sudden startling flash from a fleeing squid, or a hypnotic pulsing pattern from a deep-sea jellyfish, drifting lazily through the water. Each display is a silent, fleeting message, a personal beacon in the profound dark. Consider the diverse purposes of this internal light. A small anglerfish, for instance, dangles a luminous lure, a gentle, hypnotic spark in the darkness, attracting unsuspecting prey closer to its silent jaws. It's a quiet deception, an invitation to a final stillness. Other creatures use brief, intense flashes to momentarily blind or disorient a predator, creating a precious window for escape into the encompassing blackness. Some schools of shrimp might release clouds of glowing fluid, a sparkling smokescreen to confuse their pursuers. Even the subtle art of counter-illumination allows some species to camouflage themselves, emitting a soft glow downwards that matches the faint residual light filtering from the surface. effectively erasing their silhouette against the distant, almost imperceptible glimmer. This quiet dance of light and shadow is a fundamental language of survival in the deep, yet bioluminescence is but one thread in this complex sensory tapestry. Another, perhaps even more ancient and pervasive, is chemoreception, the deep-sea equivalent of smell and taste. You can visualize the deep ocean as an immense, flowing tapestry of dissolved chemical information. Every living entity, every instance of life and death, every geological exhalation from a hydrothermal vent, releases a unique chemical signature into the water. Deep-sea organisms have developed exquisitely sensitive chemoreceptors, allowing them to read these invisible messages. A faint, lingering scent of a decaying meal, carried on a subtle current from miles away, might guide a deep-sea scavenger to a rare feast. The precise chemical trail left by a potential mate, a silent, molecular invitation, can be followed with remarkable precision across the vastness. Even the presence of a predator might be detected through the subtle chemical alarm signals released by distressed prey, prompting a quiet, cautious retreat. These chemical whispers form an intricate, continuous dialogue, allowing creatures to map their surroundings, identify others, and locate vital resources in a world where visual cues are largely absent. It is a world navigated not by the grand, sweeping vistas of sight, but by an intimate, meticulous understanding of molecular patterns and flows. The quiet revelations from scientific submersibles, gently exploring these profound depths, often show researchers observing these silent sensory interactions. They witness creatures moving with purpose, guided by these unseen forces and self-generated glows, existing in a realm that would otherwise be utterly blank to our surface-adapted senses. These organisms are living testaments to the boundless creativity of evolution, demonstrating that perception is not solely dependent on external light or loud sounds, but can be crafted from the most subtle of elemental exchanges. Our quiet journey into the abyssal deep now leads us to ponder a profound question. How do creatures communicate in a world of perpetual night and immense pressure? A world where silence reigns. We turn our attention to the subtle, ancient languages of the deep, the unseen conversations that have unfolded across millions of years, shaping life in the most challenging of aquatic realms. Imagine a world where visual cues are fleeting, and sound travels differently through dense water, often over vast distances, but without the precision of closer interactions. Here, communication is an art of subtlety and efficiency, a symphony of molecular whispers and gentle, ethereal lights. One of the most ancient and pervasive forms of communication in these deep aquatic worlds is through chemical signals. You can picture it as a vast, continuous exchange of invisible messages, carried by the slow currents and diffusion through the water. Organisms release specific molecular compounds, known as pheromones, into their environment. These chemical messengers travel, conveying vital information to others of their kind. A faint, precise chemical trail might guide a potential mate across immense, dark distances, a silent invitation in the endless night. Similarly, a distressed creature might release alarm chemicals, a quiet warning that causes nearby kin to disperse or seek shelter. These molecular conversations allow for reproduction, predator avoidance, and even the subtle marking of territories, all without a sound or a visible gesture. Then there is the mesmerizing language of bioluminescence, the self-generated light we have gently explored. In the profound dark, light itself becomes a powerful means of expression. Imagine a deep-sea anglerfish, its gentle rhythmic pulse of light serving not just as a lure for prey, but perhaps also as a signal to other anglerfish, indicating presence or availability. Different species, and even different individuals within a species, might employ unique patterns of flashes, specific colors, or subtle alterations in intensity, much like a silent glowing code. These transient displays can be courtship rituals, intricate light dances performed in the darkness to attract a partner. Or they might be used to confuse, a sudden burst of shimmering light to disorient a predator, creating an escape opportunity. This silent, luminous dialogue weaves a delicate, ephemeral tapestry of communication through the dark waters. Beyond light and chemicals, subtle mechanical cues also play a vital role. The deep ocean is not entirely devoid of movement. Gentle currents, the passage of other creatures, and even the tiny vibrations created by swimming can generate pressure waves. Many deep-sea organisms possess specialized sensory organs, often along their bodies, allowing them to detect these minute changes in water pressure. You can imagine a fish sensing the distant, rhythmic displacement of water from a larger animal approaching, a silent awareness of its surroundings. This mechanosensory communication, a quiet apprehension of movement, allows for navigation, detection of prey, and avoidance of predators, without the need for visual contact. Even the ancient, simple organisms, such as early single-celled life and colonial forms, communicated through chemical signals, guiding their growth, coordinating their activities, and defending against threats. These rudimentary forms of interaction laid the groundwork for the more complex languages that would evolve over geological timescales. The language of the deep, then, is one of quiet subtlety and profound adaptation. It speaks of an environment that demands ingenuity, where communication is not loud or overt, but instead relies on the delicate interplay of chemistry, light, and pressure. This deep understanding of subtle cues allowed ancient aquatic worlds to flourish, creating interconnected ecosystems sustained by silent messages. Our quiet exploration now leads us to consider a vast, undisturbed library of time, hidden beneath miles of tranquil water, the abyssal ocean floor. Imagine it as the Earth's most profound archive, a place where history is not merely recorded, but gently laid down, layer by silent layer, over unimaginable stretches of time. Here, in the deepest, stillest parts of our world, are locked the evolutionary secrets of deep time, waiting patiently to be revealed. You might envision the deep ocean bed as an immense, soft blanket, composed of fine sediments that have drifted down for millions upon millions of years. This quiet sedimentation, largely undisturbed by storms or strong currents, creates an unparalleled record. Each new particle settling gently upon the last, like the soft falling of snow, encapsulates a moment in Earth's past. Within these ancient layers lie the subtle imprints and fossilized remains of creatures that once moved through the primordial waters, offering silent whispers of their existence. The process of fossilization in the deep sea is often different from that on land. The cold temperatures, the immense pressure, and sometimes the low oxygen levels create unique conditions for preservation. Soft-bodied creatures, which rarely leave a trace in shallower, more dynamic environments, can sometimes leave delicate impressions here, their fleeting forms captured in the fine mud as it slowly turns to stone. You can almost feel the quiet reverence these fossilized imprints command, a fragile testament to life's ancient dance. Among the most common inhabitants of this deep archive are microscopic fossils. Billions of tiny shells from organisms like foraminifera and radiolarians, once living near the surface, quietly rain down to the ocean floor upon their passing. These delicate structures, often no larger than a grain of sand, are exquisite time capsules. Their shapes, their chemical composition, and their arrangement within the sediment layers offer a detailed chronicle of past ocean temperatures, salinity, and nutrient levels, tracing the subtle shifts in our planet's climate across epochs. Deeper still, scientists carefully extract core samples, long cylinders of sediment, that represent millions of years of Earth's history. Observing these cores, researchers can find not only the microscopic remains of surface life, but also the quiet echoes of ancient deep-sea communities. Imprints of long-extinct deep-sea worms, fossilized remains of strange fish, and even the mineralized structures of ancient hydrothermal vents, now dormant, lie preserved in the dark, cold embrace of the abyss. These discoveries reveal that the deep ocean has always been a realm of enduring life, adapting and evolving across geological timescales. These abyssal fossils unlock profound evolutionary secrets. They show us how life first adapted to extreme pressure and darkness, how chemosynthetic communities thrived in the absence of sunlight, and how various deep-sea lineages have slowly changed over time, a testament to the immense patience of natural selection. By studying these ancient forms, scientists can reconstruct the quiet journeys of migration and diversification that have shaped the deep-sea ecosystems we observe today. The deep ocean floor, with its vast collection of fossilized remains, serves as a comforting reminder of the enduring nature of life and the Earth's continuous story. It is a silent witness to countless generations, a gentle repository of biological wisdom, reminding us that even the most fleeting existence can leave an indelible mark upon the vast canvas of deep time. The quiet revelations held within these ancient abyssal archives connect us to the earliest stirrings of life, offering a tranquil sense of continuity in the cosmic flow. Our quiet journey now culminates in a contemplation of the deepest, most enigmatic frontier on our own planet, the abyssal ocean. Imagine this realm not just as a physical space, but as an unending mystery, a vast, silent world beneath the waves that continues to whisper secrets about life's most extraordinary adaptations and its boundless resilience. It is a place where every discovery deepens the sense of wonder, reminding us how much remains to be gently unveiled. You might envision the immense scale of this unexplored territory. Despite centuries of human curiosity, vast stretches of the abyssal plain, countless canyons, and deep trenches remain largely unobserved, their secrets held in the profound dark and under immense pressure. We have merely touched the fringes of this colossal biosphere, like guests quietly peering into a vast, unlit chamber. Each gentle probe, each silent submersible descent, brings back fragmented glimpses of a world so alien, yet so intimately connected to our own. In this ultimate frontier, life has sculpted itself into forms that challenge our understanding. Creatures of the abyss are living monuments to ingenuity. Their bodies are often translucent, designed to yield to the crushing weight of the water, rather than resist it. Their metabolisms are slow, conserving precious energy in a resource-scarce environment. And their senses are finely tuned to perceive the most subtle cues, the faint chemical whispers of a distant meal, the gentle pressure changes of an approaching presence, or the soft internal glow of bioluminescence, a self-generated light that transforms eternal night into a canvas of silent communication. The quiet, persistent work of researchers who venture into these depths is a testament to humanity's enduring curiosity. They observe the soft undulations of unique life forms, measure the gentle chemical exchanges, and patiently collect samples from the deep sediments. Each observation, each quiet revelation, adds another piece to the mosaic of abyssal life, expanding our understanding of the conditions under which life can not only persist but thrive. Their silent dedication slowly peels back the layers of this profound enigma. The contemplation of life in the abyss offers a powerful reflection on the potential for life beyond Earth. If life can flourish in our planet's darkest, coldest, most pressure-filled environments, relying on chemosynthesis rather than sunlight, then perhaps similar forms of existence could arise on distant icy moons, warmed by internal geological forces. The quiet resilience of deep-sea ecosystems serves as a hopeful whisper, expanding the cosmic possibilities for life's presence across the universe. The deep ocean, then, is more than just a part of our planet. It is a profound lesson in adaptation, a living archive of Earth's history, and an enduring symbol of the unknown that still beckons. Its unyielding silence and profound depths harbor an unending mystery, a continuous invitation to quiet contemplation. The gentle, persistent dance of life in the abyss reminds us that even in the most challenging of conditions, existence finds a way to express itself, unfolding with a quiet, persistent beauty that resonates with the deepest patterns of the cosmos, forever inspiring wonder and a peaceful sense of the infinite.